Here's a little review before we move on. Remember that the population is everyone the researcher hopes the results of the study will generalize to. Perhaps the researcher does have access to everyone in their population and can conduct descriptive statistics on the whole population. However, more times than not, the researcher only has a small sample from the population. Usually people are the experimental units or observational units in psychology. These units are whatever the researcher is collecting data on. The sample size is the number of experimental units or observational units in the sample. In psychology, the sample size is usually the number of people in the study. The population size is the number of experimental or observational units in the population. In psychology, the population size is usually the number of people in the population. We will use a lowercase n to represent the sample size and a uppercase N to represent the population size. A frequency is the number of experimental units or observational units in a specific category. The sum of all the frequencies for all the categories in a variable is equal to the sample size or population size, depending on if you are conducting descriptives on the population or on the sample. Here's an example of how to get frequencies for a variable called dog owner. You see over here in orange, we have the sample data. We have two columns. The first column is the ID. The ID is the identification for that person in the sample. And in this case, we give IDs with numbers. And so we have 5 people in our sample. The other variable is called dog owner. People could say, yes, they're a dog owner. No, they're not a dog owner. So we want to get the frequencies for each category in the variable. Dog owner. We have 2 categories. We have the category yes, and we have the category no. So you want to count how many people are in each category. So first we'll count how many people are in the yes category. There's 1, 2, 3. So there's 3 people in the yes category. Then we want to count how many people are in the no category. There's 1, 2. And then if you want to get the sample size, which is a little n, you want to count how many people are in the sample. So we had 1, 2, 3, 4, 5 people. I also told you that the frequencies in each category should add up to the sample size. So we had 2 categories, and in the first category we had 3 people, in the second category we had 2 people, and that adds up to 5. So check on that. Now we're going to move on to proportions. A proportion is calculated by taking the frequency for a category and divided by either the population size or the sample size, depending on if you're conducting descriptive statistics for the population or the sample. All proportions range from 0 to 1. So 0 would mean that there's no frequency for that category, so that category does not exist really. And to 1, which means that every one is in that one category. So if you divide the frequency by its population size or the sample size, and those 2 things are equal, you'll get a value of 1. A proportion can be expressed as fractions or decimals. It can never be negative because the frequency can never be negative. You can't have a negative count of something. And proportions of all categories in a variable will add up to 1. Now we're going to go back to our dog owner example, but we're going to talk about proportions. So remember, in the yes category there were 3 people who said they were a dog owner, and 2 people said no, they were not a dog owner. But now we're going to talk about how to get the proportion. So there were 3 people who said that they were dog owners. So that's the number of people in that category was 3. And we're going to put that over 5, which is the sample size, the total number of people. Now that would be the proportion expressed in a fraction, 3/5, but we can also express it as a decimal. So if you put that in your calculator, 3 divided by 5, you'll get 0.60. We can do the same thing for not dog owners. So the 2 people said no. So that's a number in the category, which is 2, and we can divide that by 5, which is the sample size. And again, we can express that also as a decimal. So you take 2 divided by 5, you get 0.40. Remember that I said proportions can be expressed as fractions or decimals. I also said that they'll range from 0 to 1. So this 0.60 and 0.40 is from 0 to 1. It's in that range. I also said that they can never be negative, which is the same thing as being between 0 and 1. It can't be below 0, so it can't be negative. And then finally, that the proportions of each category for a variable should all add up to 1. So let's make sure that's true. So we have 0.60 plus 0.40. And if you add that up in your calculator just by looking at it, that will equal 1. So check on that. So if that doesn't happen, if each of the proportions in each of the categories for a variable don't all add up to 1, then you did something wrong. So that's just a check. Now we're going to talk about percentages. Percentages are just proportions, but instead of being out of 1, they're out of 100. You can take the decimal form of the proportion and multiply it by 100, or you can just move the decimal place to the right twice. Percentages takes on values from 0% to 100%, and because it goes from 0% to 100%, they cannot be negative. Now you never hear of a negative percentage, right? And the percentages for each category in the variable add up to 100%. So now we're going to go back to the dog owner example, but now we're going to find the percentages for each category. So what percentage are dog owners? Well, first you find the proportion again. That was 3 divided by 5. We got 0.60. Now you can multiply that by 100. And you'll get in your calculator 60. And we're going to put a percentage sign at the end. Or you can move the decimal place over twice from the decimal form. 1, 2. Then we go to the second one. What percentage are not dog owners? We do 2 out of 5. Because there's 2 not dog owners. And that equals 0.40. We're going to multiply that by 100. And you'll get 40%. Or again, you can move the decimal over twice. Remember I said percentages can go from 0 to 100%, and that's true. 60% and 40% are in that range. I also said if you add them up, it'll equal 100%. So if you add up each of the percentages for all the categories, there are 2 categories for this example, dog owners and not dog owners. And so if we add those 2 percentages up, we'll get 100%. So 60% plus 40% equals 100%. So that's a good check. It worked out, So that probably means that our percentages are correct. Now we're going to talk about frequency tables. Frequency tables organize frequencies, proportions, and percentages into a nice little table. Here's a frequency table for our variable dog ownership. At the bottom here, at the top is the original data. So in the first column here, we have the category. So the variable can take on either dog owner or not dog owner. So they said yes, they were a dog owner, or no, they were not a dog owner. Then the second column here is the frequency. So there's 3 dog owners, 2 not dog owners. And then we have the proportion in the next column. And then in the last column we have the percentages. And at the bottom we have the totals. So remember, the frequency should all add up to the sample size, which in this case is 5. The proportion should all add up to 1. And the percentages should all add up to 100%. I'm going to talk about an ungrouped frequency table versus a group frequency table. And first off, here we have an ungrouped frequency table. So it's just the individual categories and their frequencies.